Hi there, this is Srikant Dasare. So in this lesson, we are going to learn about the very basics of object-oriented programming. Okay. So first and foremost, we are going to learn about so what is the most basic feature in object-oriented programming. Okay. So this is going to be a purely theoretical lecture. Okay. The first feature which I am going to tell you is about data hiding. Okay. So if you take any object-oriented programming language, so I have just opened Sublime Text here to type some of the text. Okay. If you take any programming language like object-oriented programming languages like C++ or Java or Objective-C or C Sharp. Okay. So all these languages have some constructs inbuilt into them according to these OOPs features only. Okay, the first OOPs feature which we are going to discuss is what we call data hiding. Okay, so this is the first OOPs feature. So here I am using Sublime Text to automatically the line numbers gets attached. Okay, so I need not type 0.2 or 0.1 something like this. Okay, so data hiding. So okay, so what do you think is data hiding here? Okay, so data hiding means hiding the essential features from the user and only giving him the details whichever is required for him. Okay, whichever are required for him. Okay, so with the best example I can give for this is so if you take what we call ATM. Okay, so if you're walking into an ATM machine, and if you're swiping your card and you are giving the details like your PIN number, and if you check the balance, or for the only your balance will be displayed on the screen. Okay, so never in the world other person's balance will be displayed on your screen. Okay, so unfortunately this doesn't happen because of the security purpose. Okay, so if you want to, okay, so that is what we call data hiding here. Okay, so if you take another example like so if you are opening the Gmail or Yahoo Mail or any other mailing kind of service, there if you enter the login page and if you are giving the details like username and password, the only your mails get displayed. Okay, so the user must be served according to his login credentials or only the data which he is allowed to view. Okay, so he must not be shown the other details. Okay, so this is what we call data hiding, so which can be achieved in object-oriented languages like C++ or Java using access specifiers kind of thing. Okay, so we have private, public, protected, and also in Java we have default, such kind of things. Okay, so the second feature which I am going to discuss is about data abstraction. Okay, so let me type that. So data, so abstraction, so the name itself suggests. Okay, so both of them look very identical. Data abstraction is also covering up some sort of covering up of details, and also here there is a slight difference between both of them here. Okay, so data hiding means hiding the content here. Okay, so hiding the actual data. So when it comes to data abstraction, it is not about the hiding data, it's about hiding the implementation. Okay, so here within a one sentence we can say that data hiding is all about hiding the data. Okay, actual data, you can say actual data. Okay, so when it comes to so when it comes to data abstraction, you can say it in a one word. It's all about. Okay, so it's all about hiding the implementation details. Okay, it's all about hiding the implementation details. Okay, so when it comes to data abstraction, it's all about hiding the implementation details. Okay, so the best example I can give for this OOP feature is again an ATM machine. Okay, so if you walk into an ATM machine, and so if you are habituated with the screen, it asks you to swipe the card and give the PIN number, or it can perform various operations on the screen, but you are least bothered about which technology has been used underlying the ATM machine. Okay, so you don't know about on which language they have developed the ATM screen here. Okay, or else which database they have used, or where the servers of this ATM has been located, all those things. Okay, so if we if our over enthusiasm has crossed the limit, and if we ask those bank people all these details, and they might think that we are all hackers. Okay, so there is a chance that they might be thinking that we are all hackers and some kind of stuff. Okay, so that abstraction, the users, for example, in a bank scenario, so if the users are just should bother about the familiarity of the screen which they are using. Okay, so they are least bothered about so whatever the details underlying how they implemented the system, the users must be least bothered. Okay, so this is also for security purpose. The abstraction can also be achieved in object oriented. This is another important feature. So like these important features were lacking in the previous programming paradigm, like structured oriented programming language like C or any other language. So all those languages don't lack these kind of features. So for this purpose, the object-oriented programming language gained huge popularity, and that popularity is still going on these days. Okay, so next feature we are going to discuss about is encapsulation. Okay, so encapsulation. Okay, so what do you mean by encapsulation? Okay, so this is another the most important OOP feature with regard to any typical object-oriented programming language. Okay. So to what is encapsulation? To say it in a single sentence, we can call encapsulation as, if you think like a capsule. Okay, so where more than, if you take a medical capsule, where more than one drug is enrolled into or wrapped into a single drug. Okay, so likewise here in our programming technology, we use the term encapsulation, where the data members and member functions are wrapped into a single unit. Okay, so actually if you go back to the C structures, old school C programming, so there we have what we call structures. Okay, so if you remember the structure, the typical syntax of a structure is going to look like this. Okay, some struct student, something like this. Okay, some struct student, and they might give you some data like int some roll number, so int some roll number, and so on and so forth, and char and the name, and char and name, and so on and so forth. Okay, so store the name of the student. Okay, so the C structures lack one thing. Okay, so they only have the data members, or we call properties. They don't lack the actual functionality. Okay, so actual functionality comes so when you use the functions. Okay, in C, the biggest problem is that the functions are written outside the structure, and this structure must be passed to that function, or this structure must be declared globally above the main, and that structure can be the members of that structure can be accessed inside the function. Okay, so these kind of things made a nightmare for the programmers when it comes to data redundancy or security or tampering of data. So all these things have become a huge problem. Okay, so for this purpose they eradicated the whole thing called as structure, or else they have built a new type on the structure known as class. Okay, so class is the best example for encapsulation. Okay, so in class what we are going to do is we don't let the functions move freely outside the structure. Okay, so we encapsulate those functions also within the class here. Okay, so with the class we can encapsulate the data members, like if we take the same data members here also, so roll number, and if we take another data member like char name. Okay, so with this we can also have we can take member functions. Okay, so void, or I can say void get void get or something like this, you can have some functionality within the class. So functionality within the class, and we can perform some operations on this data. Okay, so this is the huge advantage if you are using this class data type, abstract data type. Okay, so abstract data type. Okay, so structures in C and classes in C++, or the classes in C++ is the best example for encapsulation. So where we can encapsulate both data members and member functions into a single unit. Okay, so here in the within the class we can achieve both the data abstraction and data hiding features with access specifiers. Okay, so with access specifiers. Okay, so what do you mean by access specifiers? So access specifiers are most commonly used of private and public, and protected. Okay, so private, public, and protected. Private, public, and protected. And also we have in the case of Java we have default also. Okay, in the case of Java we have a default. Okay, so these are the most commonly used access specifiers in any object-oriented programming language. So these control the accessibility of the variables or methods which were written inside the class. Okay, so if you say private, they were never accessible outside the class. Okay, so if you say public, they are accessible outside the class from anywhere. Okay, so if you say protected, it's also works like private, but the members were given the access to the outside the members were given access only to the classes which were inherited. Okay, with regard to C++, I am talking here. Okay, so not seriously into those how they behave in different. So the behavior of these access specifiers differ from one object-oriented programming language to other object-oriented programming language. Okay, so this is about encapsulation. Okay, so wrapping up of data into data members and member functions into a single unit. So let me write that code also here. Okay, so if you say something like that, the definition: the wrapping of data members, and member functions, into a single unit. Okay, into a single unit is known as encapsulation. Okay, so now we are moving into the next OOP feature, which is known as object. Okay, so just now we have discussed about the class with regard to the encapsulation. The class is the best example of encapsulation, which means that wrapping up of data members and member functions into a single unit. Okay, so class is also known as a blueprint. Okay, so class is a blueprint of what you are going to build. Okay, what you are going to build. Okay, so class is also known as a blueprint of what you are going to build. Okay, so if you take the construction field. Okay, so there what happens is before constructing any building, so first you need to give some plan. Okay, so first you need to give some building plan or some kind of plan, and then according to that plan, so you build the actual product here. Okay, so in the same way the class acts as a blueprint. Okay, so now the important thing is with regard to classes is known as object. Okay, so object is an instance of a class. Okay, so object is known as an instance of a class. So writing a class, nothing happens. Okay, so if you want to build the actual component, you need an object here. Okay, so here the best example is that so if you construct a class for car. Okay, so all the basic features of the car, like the number of tires or speed and cost, all those things were included in that class. So when you are constructing objects, you can say the objects for that class car can be Maruti or Ford or Skoda or whatever it might be. Okay, so all those objects are real world entities. Okay, so in reality, so object is also known as a real world entity. Okay, So object exists in reality, the class is just a blueprint. Okay, so this is about the object, which is the instance of a class. And also objects are very essential. So if you want to store some data inside the class, or if you want to retrieve some data from the class, so you need the object. Okay, so next moving to the next OOP feature, which is known as inheritance. Okay, so inheritance is another important OOP feature. Okay, so what do you mean by inheritance? Okay, by the name itself, we can say that inheritance is nothing but deriving a new class from the existing classes. Okay, so this is a very important OOP feature which increases the code reusability and also reduces the redundancy of the code. Okay, so you need not write the same classes again and again, or the same functionalities again and again. So if you put all the common functionalities in a single class, and you can derive as many as classes possible from that root class, and you can create subclasses, which sometimes also known as child class. Okay, so the inheritance is another OOP feature. Okay, which gives the ability of deriving new classes from existing classes. Okay, so deriving new classes from existing classes. Okay, so the derived class is known as, so here the derived class is known as child. Okay, okay, so you have child class, and the actual class from where it should, the actual class, so where it has been derived is known as a parent. Okay, the actual class or the main class or the root class is known as a parent. You can also take this as a parent-child relationship. Okay, so parent-child relationship kind of thing happens with regard to the inheritance, which increases the code reusability, the concept of code reusability, and it reduces the redundancy of the code. It's a very important OOP feature. Okay, so and the last OOP feature which we are going to look is known as polymorphism. Okay, so polymorphism is a Greek word. Okay, so polymorphism is a Greek word which has the meaning that many forms. Okay, so poly means many, morphism means forms kind of thing, so many forms. Okay, so this is a very important OOP feature. So for example, the mostly used polymorphic features in languages like C++ or Java are function overloading. So okay, so many forms. Polymorphism means many forms. Okay, so many forms. Okay, so polymorphism can be achieved in two ways mainly, which is the first one is function overloading, and second one is operator overloading. Okay, so although in Java Java language, at a language level, Java does not have any support for operator overloading. Okay, the function overloading is supported by Java, C++, and also operator overloading is supported by C++. Okay, so what do you mean by function overloading? Okay, the same name, okay, but different functionality. Same name, different functionality. You can use the same name to the function for different functionalities. Okay, so why in the world you think that you need a same name for different functionalities? You might get that doubt here. Okay, so for this purpose, okay, so for example, if you go back to C, there we have different kind of functions for ABS, for of int type we have, and also for LABS, I think for LABS for long type. Okay, and also we have FABS, absolute value. To calculate the absolute value we have for float or double. Okay, so we have different kinds of functions here for different for the same functionalities. Okay, the same functionality is to find out the absolute value, but in C language, which does not support function overloading, which is not object oriented, we need they tend to use different names for different same functionality here. Okay, so here there is a problem that the user must remember or the programmer must remember all the terminologies, which is a very painful process. Okay, so coming to the C style. Okay, I'm putting a comment here. I'm telling C style functions here. Okay, so C style functions without function overloading, without overloading. Let me say that overloading is enough here. Okay, so without overloading. When coming to C++, style functions functions, we have overloading with overloading. Okay, so they come with since C++ supports overloading, the problem is solved here. Okay, or else if Java style, you can say so. C++ is also a superset of C, so these functions may also be used in C++ also. Okay, so coming to Java style functions, so Java style functions with overloading, we have only one function for ABS. Okay, so ABS, we have only one function for ABS which can be used for int, and the same function can be used for float, which can, if you pass a float data, it works for float. It works for float kind of thing. Okay, so float data. Okay, floating point data, and also we have ABS for double. If you say double, it works for double, and so on and so forth. Okay, and so on and so forth. So we can have same function. It works according to the argument which you have passed here. Okay, so this is all about the function overloading, which is an important OOP feature known as polymorphism. Okay, and then we have operator overloading. Okay, so operator overloading, which means that in language like C and older language doesn't have this feature. Okay, so operator overloading means that, so actually the operators like plus or subtraction or asterisk for multiplication, so all these types were all these operators were built to operate on primitive data. Okay, so primitive data like variables. Okay, so variables which were declared within the primitive type. So these basically they were designed for using on the primitive data. Okay, so when it comes to operator overloading, we can make these operators work on objects also. Okay, so if you're saying some class foo. Okay, so if the foo, I'm taking here a class foo, so if I have some 2 objects for this, or else if you say 3 objects for this foo class here. Okay, so I think that this is the main, and I have created 3 objects here with respect to C++ code I'm writing here. So I think that I created 3 different objects here. Okay, so here my intention is to make use of this plus operator. Okay, so plus operator, and F3 is equal to F1 plus F2. Okay, so F3, so now F3 has the data combined of all the objects of F1 and F2. Okay, so that for example, if you can take strings. Okay, so you can take some strings within this class foo, and you can put those you can use this plus operator to concat those strings also. Okay, so likewise you can implement the plus operator, which is basically built to work on primitive data on the objects also. Okay, so this is about the another important loop feature known as operator overloading, which comes under the polymorphism. Okay, so these are the most commonly used important OOP features. So just to summarize all the once again, so we have data hiding, data abstraction. So data hiding is nothing but it's all about the hiding of actual data, and also we have data abstraction, which is all about hiding the implementation details. Okay, the user must be least bothered about how the system is being implemented. And also we have encapsulation, which is nothing but wrapping out data members and member functions into a single unit. The best example for encapsulation is class. Okay, so and also we have inheritance, class and object. Class is a blueprint. Okay, it's also an example of encapsulation. And also we have an object, which is an instance of a class. Okay, and also we have the inheritance, which is very important OOP feature, which allows us gives the ability for the programmer to derive classes from the existing classes or create new classes from the existing classes. Okay, and also we have polymorphism, which is achieved in 2 different forms, which is function overloading and operator overloading. Okay, so see you in the next lesson. Good.